sequences work like arithmetic sequences, except instead of adding a constant number, we're going to be multiplying by a constant number. Okay, so you might have a geometric series that looks like this: 100, 50, 25, 12 and a half. Okay, and when you're looking for, instead of D, we're going to have R, okay, as the common, instead of a common thing we add, we're going to have a common ratio, something we multiply. Okay, and that ratio could be a whole number, like 2 over 1, but, or 1 over 2, or it could be like a weird fraction, like 7/9. You know, just depends on what the ratio is. All right, but so just like yesterday, you need to find R. You need to know what a sub 1 is, and it's always the first term. And then we're going to just plug it into the formula. But just again, like yesterday, we're going to first determine if it's geometric or arithmetic. Because like on the ACT, that's one of the things they do is they give you the sequence, but they don't tell you which it is. So you've got to stop first and say, okay, is this arithmetic or geometric before you can use the formula. All right, so, well, this one's kind of obvious to look at. What's it getting multiplied by each time?
2.
Well, we're multiplying by 1/2, right? Does R, because R is always what you're multiplying by, it's always good. Instead of saying divide by 2, it's better to say multiply by 1/2. Even though I know it's the same thing. It's just, put yourself in that mind frame. It's what you're multiplying by. All right, and if that ratio isn't easy, like sometimes the ratio, again, is 7/9, and it's hard to tell. So what you do to get the ratio is, like, you know how this is a sub 1, a sub 2, a sub 3. Write the ratio. Like, to get the ratio from here to here, it would be a sub 2 over a sub 1, which is 50 over 100, or 1/2, right? And if you want to make sure it's a geometric sequence, if you want to make sure it's all right, then you would write a sub 2 over a sub 1 and check that one. Then you do a sub 3 over a sub 2 and make sure it was the same. And then a sub 4 over a sub 3 and make sure that's the same. Right? Okay? And as long as they all come out to have the same ratio, then it's a geometric series and you know what R is, or sequence, and you know what R is. Okay? Make sense? So take a minute, do these 4.
It's the same equation.
No. We'll get one. Yes? Well, what's the ratio of the first two? 3 over 2. What's the ratio of the second two? Right. Yeah, it's 15 over 10, which is 3 over 2, and then 20 over 15, which becomes, if I divide by 5, becomes 4 over 3. And those are different, so it's not a geometric sequence. Okay? Pretty easy to tell? Okay. The rule for geometric sequences that takes the place of the arithmetic, which was a sub n equals a sub 1 plus n minus 1 times d. Well, when we were adding, we were trying to figure out a way to show that we're adding 3, 15 times, right? 3 plus 3 plus 3 plus 3. So that's why we did the number of terms there are, n minus 1, times d, times the number 3. Well, this time we're going to be multiplying 3, for instance, to figure out how many times we're going to multiply by 3. And when you multiply a number by itself over and over and over, what do we usually use to show that? How do I show 3 times 3 times 3 times 3 times 3?
Squared.
A power, right?
Power.
Yeah. Squared is there were only 2, right?
Yeah, right.
Okay? So that's why instead of a number times r, we're taking r and raising it to a power, because that's how we show multiplying by itself that many times. All right, so it's the same a to the first, or a sub 1 times, and then our amount that's going up raised to the n minus 1 power. Again, it's n minus 1 because we've already used the first term. So we're going to go out to the nth term, but it's going to be one short of the total. Okay? And this is almost easier because there's not a lot of math you have to do. If I want to write a rule for the nth term, okay? First of all, I need a sub 1 and I need r. R is 5, right? 4 times 5 is 20. 20 times 5 is 100. 100 times 5 is 500. And a sub 1 is 4, our very first term. Okay? And then I just plug it in my formula. So my general rule, a sub n, is a sub 1 times r to the n minus 1. And I'm done. I don't even have to clean it up.
That's it?
Yep.
Oh my gosh.
I know, that part's
Is it
easy.
Yeah, but
20
something you can do,
minus
Tyler.
5?
I'm sorry?
Is it
I missed
20
you.
minus 5?
5. It's r. Yep, it's just r. I see what you're saying. No, can we multiply? Or could you multiply 2 times 5 to the third? No, you can't multiply the 2 and the 5 because one's being raised to a power and one isn't. So you have to leave it 4 times 5 to the n minus 1. Okay? And then find a sub 15 would be a sub 15 is 4 times 5 to the 15 minus 1. All right, so I would do, just be really careful with parentheses here, guys. Right.
Whoa.
That was magical.
What?
Calculator disappeared.
Oh. So I would do 4 times 5 to the, and I'll be, like I said, be really careful because you've got to make sure that if you, anywhere there's a fraction, you put it in parentheses. Okay? Yeah, it's 15 minus 1, so it'll be 14. Okay? And the numbers, obviously raising 5 to the 14th power, that's going to be a huge number. So it gives you the answer in scientific notation. So the answer would be 2.44 times 10 to the 10th. Okay? And I got that from e to the 10. That's scientific notation for 10 to the 10th. So it's 2.44 times 10 to the 10th.
So would it be 2.44 to the 100
Yeah.
if you...
I'm sorry?
Would it be legitimately 2.44 to the 100 if you take out the 10?
No, 10 to the 10th.
10 to the 10th. 10 to the 10th is 10
10
times 10
times
times 10 times 10
10
times 10 times 10 times 10 times 10.
I'm good.
Never mind, Tyler. I don't think I can do this.
Okay? All right, take a second and
I initially had faith in you, but now I have my faith.
Okay.
I initially had faith in Tyler to be able to do this, but
All right, so go ahead and do these two. Do 152. Do this orange one and this this green one over here.
So what is that, like a negative 1/2?
there you go.
Yeah.
You're on your way, kid.
Are we doing the next one?
Do this orange one and this green one.
Okay.
Geometric series get really big or really small really fast.
This thing is so pretty small.
That'd be
A sub 15.
Yes. please do a sub 15 after you're done.
Okay, so
So,
if this is,
if this what?
if that applies to that, then basically what you gotta do is you gotta go 152, and then you gotta figure out distance between all of these multiplication lines. So then you figure out that it's negative 0.5 in between these, so that becomes your R.
That's 1/2.
So negative 1/2. Okay, or you can put 0.5.
Or 1/2.
And then you go n minus 1, okay? And this is your, and this is a to the n, and this is your deal. So to find a to the 15th, you go a to the 15th equals sub 15th. 152 times negative 1/2
Negative 1s.
to the 14th. Okay, and then
Why to the 14?
you get your answer to be
Because it's 15 minus 1.
152, and then you got to do this when you put it in the calculator, because if not, you get a negative answer, but it's negative point, it's 0.009 pretty much.
Even on this.
Huh? Yeah.
No hammer.
Okay, class.
What you gotta do is.
You change your voice like that.
Next one, sorry.
Like you might be gay or something.
You only got 3 minutes.
The a to the 6 is negative 96, so you start negative 96. Because you have to find what a sub 1 is. So you do equal to a sub 1 times 2, since that's the common ratio. And then 6 minus 1 is 5, since it's the a sub 6. And then you do negative 96 is equal to a sub 1 times 32, since 2 to the 5th is 32. Divide by 32 to cancel it out. And then negative 3 equals a sub 1. And then to find the rule, you do a sub n is equal to negative 3 times 2 n minus 1.
Here's